Okay, this is the first essay question from the 2017 Devi Balika November grade 12 paper. But let's see what it's all about. Two trains X and Y travel on two parallel tracks in same direction with uniform accelerations 15 ms minus 2 and 10 ms minus 2 respectively. Pass a railway station A at the same instance. The speeds of X and Y at that instance are 72 kilometers per hour and 108 kilometers per hour respectively. After some time, the train X passes Y at place B. Okay, let's try to draw a diagram now. A is the railway station. X and Y are traveling in parallel tracks. Well, when X passes station A, it has a velocity of it has a velocity of how much? It has a velocity of 72 kilometers per hour. 72 kilometers per hour. Right. So just mark it 72 kilometers per hour. People, I hope you know how to convert kilometers per hour to meters per second. Now, if 72 kilometers per hour, it is actually 72 into 5 by 80. That is 20 meters per second. Okay, 18 and 72 you can simplify. 1 and 4 here, 20 meters per second. So I will write that. And the other one, let's use a different color for y. Y is traveling at what speed? It's passing that point at 108 kilometers per hour. So if it is passing at 108 kilometers per hour, what do you do? 108 kilometers per hour, when you convert it to meters per second, you have to multiply that again by 5 by 18, which is 6 into this 30 meters per second. So the velocity is 30 meters per second when it passes. Now you can see initially y has a larger velocity than a. So after this point, y will overtake x and move forward. I'm sorry, I said a, I think, instead of x. X is moving at a lower speed. Y is passing a at a higher speed. So at the beginning, y will be moving forward. But if you look at the accelerations, x has a larger acceleration, and that is 15 ms minus 1. 15 ms minus 1, sorry, ms minus 2, beg your pardon, ms minus 2, and then the other one has only 10 ms minus 2. Correct, yeah, 10 ms minus 2. Eventually, the trains are meeting again at B, at a point B. So this is how the, if you look at that through a drone, maybe you can see this is what's going to happen, right? Train doesn't look like a dot, but I have taken like a dot. Okay, fine. Let's start. Fine. Draw the velocity time graphs of both the trains in the same axes. So let's start with that quickly. Roman 1. Right, Roman 1, you have to draw the velocity time graph. Let's quickly draw the axis, velocity axis, and then the time axis. Fine. Right, so your graph should have looked like this. Velocity in meters per second, time in seconds. We have no idea about the time though when they are going to meet. From the graph, we have to find out. Right, I'll use the same colors for both x and y. I'll continue to use the same colors. Now maroon is for x. X starts at 20 meters per second, but it is moving at a higher acceleration. Therefore, its graph is going to be like this. Okay, right. And let's say the time taken for the trains to meet, I'll take it as capital T. Okay, therefore, if you have a stopwatch, when they reach A, if you start the stopwatch, when they meet again, let's say the time in the stopwatch is capital T. Right, we will need that. And whenever you draw a graph, it's important that you mark the values as well. So let's mark this as 20. Right, 20 means 30 somewhere here. Right, then the other graph. That is for the other, what do you call the train y. Initial velocity is 30, but it has a lower acceleration. Therefore, the graph should look flatter. The graph should have looked like this. This is the graph for y. Don't forget to name the graph. Very important. You have to name the graph. Right. So this green color one is for y, and the maroon color one is for x. Right. Yeah, this is the graph done. Determine the time period which is taken by x to pass y using the above graphs. So we have to find out the time taken for them to pass. Fine. Find the speeds of x and y at that moment. Find the speeds of x and y at that moment. Okay, good. Now, this is what we are supposed to find out. Now, let's analyze this. Wait a minute. Mm, this is x. This is the speed of x when they meet. So I'll take it as vx. Okay, speed of x when they meet, vx. And speed of y when they meet, let's take it as vy, something like this. So what's the plan, guys? What's the plan? Um, shall we first of all find an equation for Vx and Vy? Now we know the main equation you can use for both the train is V equal U plus AT. Okay, V equals U plus AT. Now when you apply that equation for x, right? Final velocity is equal to initial velocity plus acceleration into time. First equation. And if you apply the same equation for y, final velocity when they meet. Now, when they meet, the velocity of y is vy, velocity of x is vx, right? Okay. The time taken is capital T. So we have around three unknowns. That means we need three equations. Yeah, and you do the question with the equations or with the graph as well. You can do the question with graph also. How do you do the question with the graph? You have to do that like this. Now, this area and this area must be equal. These two areas must be equal. This area and this area. These two areas must be equal. These two areas must be equal because the total area of both the uh, graphs, total area under both the curves must be same because they have reached the same displacement. You can do it that way as well. You can do it that way as well. So Vy, what is Vy now? Vy is going to be 30 plus 10t. That is the second equation. 30 plus 10t. Okay, fine. Right. So what's the plan? How are we going to do it? How are we going to do it? When their speeds become equal, definitely time has to be t by 2. Definitely time has to be t by 2. Right. You can equate this area and this area. You can do the question that way. No problem with that. If not, you can equate. Normally, you can, yeah, that's the easiest way. But if in case if that doesn't click at the exams, then the easiest way is equating the displacements of x and y. Because when they meet again, both their displacements must be same. Because when time is equal to 0, they were at A. When time is equal to capital T, they are at B. Therefore, they have both traveled the same distance. Okay, right. So let's see if we can finish it off quickly. When they meet, when the trains meet, displacements are equal. Right. Yeah. Now, displacements of x should be equal to displacement of y. What is displacement of x, people? Displacement of x is area under the maroon line. That will be half into addition of parallel sides. What is addition of parallel sides? 20 plus vx into height. What is height? T, capital T, equal to sy. That is the displacement of y when they meet. That is half. Guys, remember both are trapeziums. Huh? So half into addition of parallel sides into height. Half into addition of parallel sides, it's going to be how much? 30 plus vy. 30 plus vy into height is again capital T. So the good news is half and capital T can be cancelled out. Half and capital T can be cancelled out. Therefore, we will end up in an equation like this. That is 30 plus Vx equals, uh, sorry, 20 plus Vx. Extremely sorry about that. 20 plus Vx equals 30 plus Vy. Now, Vx and Vy, we have already found that. 20 plus 15t equal 30 plus 10t. Okay, so 5t, how did 5t come? 15 minus 15t minus 10t, and here we have 60 and 40 here, 20. And final answer, t is equal to 4 seconds. T is equal to 4 seconds. Moving on, then this is all this time what we did here was Roman B part. No, this is B part now. This is A. The graph is A part, and this is B part. Now let's move on to part C. Find the speeds of x and y when they meet. I'll do it here and finish it off. Find the speeds of x and y at that moment. Right. That is this. Right. So Vx is equal to 20 plus 15t. Now t we have found it as 4. That is 20 plus 15 into 4. Then final answer is going to be 80 meters per second. And Vy, that is going to be equal to 30 plus 10t, and that is going to be 30 plus 10 into 4, 30 plus 40. Therefore, it should be 70 meters per second. That's pretty straightforward. We have already derived the equation. Then after this, Roman 2 happens after all this. Then x comes to rest after traveling at a deceleration of 5 ms minus 2, while the speed of y remains constant. So let's try to draw the graph again with the relevant numbers. This is how x works. Starts at 20 meters per second, and within 4 seconds we have found capital T F. So it reached a velocity of 80, and then in another 16 seconds it comes to rest with an deceleration of 5 ms minus 2. Right, that's how it works. And then talking about y, it started its motion at a speed of 30 at point A, 30, and then its velocity increased up to 70 after uh, 4 seconds. It increased up to 70 after 4 seconds, and it remains at rest. Sorry, it continues its motion at constant velocity. Like it continues its motion at constant velocity. Right. Let's mark the important points. Now this is 70. This is 70. All right. This is 70. And yeah, then it remains the same and starting at 30. This is how. Now they are asking us to draw the graph on the previous diagram itself. Therefore, you should have left some space in the previous diagram on the right. So this is how it works. Hope you can understand this graph. Right, let's draw the velocity time graphs for the motion of the trains in the same graph in 1A. That is what we have done here. So this is 1A. This graph should actually look like this by the end of the question. And in this question, after 16 seconds of total period of time, y passed x at place C. So from the beginning, after 16 seconds, at a point like this, y is passing x. Y is passing x. That's what they have told. Right. Um, Draw the velocity time graphs for the motions of train in the same graph. Right, done. That's drawn here. Up to 4 seconds we had already drawn, and the remaining part I have drawn it. Y's graph remains constant because its velocity doesn't change, and x travels with the deceleration. Find the total distance traveled by y when it is passing x. Right. They have told the total time, when the total time is 16 seconds, y is passing x when the total time is 16 seconds. So we need to find out how long, how far rather, y has traveled when the total time is 16 seconds. For second question, B part. For second question, B part. Right. Now, how do you find that? Total distance traveled by y. Traveled by y after 16 seconds. So how much is that? How much is that? You have to find the area of this trapezium plus the area of this part, and this gap. This gap is actually how many? How many seconds? 12 seconds, isn't it? This is 12 seconds. This is 12, right? So I will write an equation. See if you can agree with me. Half into 30 plus 70. 30 plus 70 into 4, that is the area of this trapezium, green color trapezium. Okay, 30 70 into 4 plus the area of this rectangular part. How much is that? 70 multiplied by 12. 70 multiplied by 12. So here it's 100 into 2, that is 200, plus 70 into 12 is 840, and the final answer is 1040 meters. Then C part, Roman 2 C part. What are they saying in that? What is the speed of x when y is passing it? So this is where y is passing it. So we have to find the speed of x by that time. Now, when y is passing from this point onwards, x also would have traveled how many seconds? 12 seconds. Okay, right. X also would have traveled 12 seconds. So we need to find out the speed, right? So the equation is this. We'll take let speed of x when time equal to 16, total time equal to 16 equal to v. Okay, right. Now I'll consider an equation like this, see if you can understand. Huh? From t equal to 4 second to t equal to 16 second. So I'm going to consider this area, this part, where x is traveling with the deceleration. So tell me the information we need. We need the final velocity during that time. What is the initial velocity, people? For x from time equal to 4 to time equal to 16, what is the initial velocity for x? Hurry up. What is the initial velocity of x for the decelerating part? Good. I have only one correct answer. It is 80. Good. It's 80 meters per second. Right. Fine. And what is the value of A? Acceleration. What should I put for acceleration? Hurry up. From here to here, what should I put for acceleration? It should be minus 5 ms minus 2 because it's deceleration actually. Not very good, right? It's decelerating, so you have to use minus 5. And for time, what should I substitute, guys? Hurry up. For time, what should I substitute? For x, 12 seconds because it has decelerated for 12 seconds. For x decelerating part, we are only considering the decelerating part of x to find this velocity, the velocity of x when it meets, when y meets it, this part 12, right? Then apply, what are we going to do? We are going to apply v equals u plus 80. Final velocity we need to find out. Initial velocity is 80 plus minus 5 into 12. And what is the answer we are getting? It's again 20 meters per second. 20 meters per second. Okay, right. So you have to apply the equation for the decelerating part of x. And when y passes x, x has decelerated for 12 seconds. 16 is the total time. Okay, so for the first for the first 4 seconds, x accelerated. For the next 12 seconds, not overall for the next 16 seconds, it's going to be decelerating. But within the next 12 seconds, y is passing x now. So during that time, you have to apply the equation and get the answer. Right. So the answer should be 20. And the next question is, we have already covered that part, this one, D. Find the total time period taken by x to come to rest. Now, if you monitor x, this is what's happening. If you look x closely, when time is equal to 0, it moves with an initial velocity of 20 meters per second. Okay. When time is 4 seconds, it has reached a velocity of 80 meters per second. And then it continues to move at a deceleration and its final velocity becomes 0. It comes to rest, right? And the deceleration for this part is given by 5 ms minus 2. I'm marking it in the opposite direction because it is deceleration. So they are asking the total time taken by x to come to rest. Now that means for that, now I know the time from here to here, that is 4 seconds. I need to find out the time from here to here, t. So how do I find that? It's very easy. From here to here, you apply v equals u plus 80. Final velocity is 0. Initial velocity is 80. Plus for acceleration, you have to substitute minus 5 because the train is decelerating into the time taken for that decelerating part, t. So 5t is equal to 80. Therefore, t is equal to 16 seconds. X has to decelerate for 16 seconds. All right. But the question is, this is the answer for D part. All right. D part, Roman 2 D part. Find the total time period taken by X to come to rest. So total time, what is the total time? Total time is going to be 4 plus 16, that is equal to 20 seconds. That's all. 20 seconds. Okay. Right. Fine. And the last part, E. So what does part E say? Roman 2 E part. Find the difference between the distances traveled by x and y when the train X comes to rest. Okay, so X comes to rest after 20 seconds, total time. Okay, now one thing you all should understand is when time is equal to C. Okay, when time is equal, you can do that question in a very easy method also. You can do this question in a very easy method. Um, now, if you and now X and Y are meeting at three different places. X and Y are meeting at three different places. Can you tell me what they are? What are those places? They are meeting at A. This is that point. They are meeting at B. That is this point. They are meeting at C. That is this point. So at C, at point C, what can I say? At point C, X and Y have same displacement. Hope you can agree with me on that. Because if you read the question carefully, they have mentioned that X and Y are meeting again. X and Y are meeting again. All right. X and Y are meeting again at point C. So they both will have the same. When if the two trains are meeting, that means they are at the what do you call that? They have the same displacement. They have the same displacement. One happened at A, one happened at B, and the other one happens at C. Now after that, they are going to separate from each other and move. After that, look at the graph after that, right? So after point C, we can consider like this after point C, because until point C, now they have somehow overtook each other. One was going forward, then the other one overtook, then the other one overtook. At point C, they are both at the same point. But after point C, look at the graph. Look at the graph carefully. After point C, velocity, time. Right. What is the graph for X? From velocity 20, it's reducing to 0 in 4 seconds. Hope you can understand this. I'm starting from this point where this is where Y passed X. So after that, what's happening? After 16 seconds, what's happening? Both the trains are moving for another 4 seconds, and X is decelerating for another 4 seconds. And what about Y? It is moving at a constant velocity of 70 for another 4 seconds, like this. So this is after point C. Yeah, keep that in mind. After point C, they are meeting, right? If not, you can do it's something like this. Until 20 seconds, you can find the displacement of both the trains and subtract. But I think that is redundant. We've been doing that over and over again. Let's try something differently. Okay, so I'm considering what will happen after point C, because at point C, they are at the same displacement. Right, fine. So look at this. Right, I'll finish it off. After point C, I have already put in after point C, displacement of Y. How much is that? Displacement of Y after point C. How much is that? How do you find it? You have the area of the rectangle. That's going to be 17 to 4. How much is that? 280 meters. Okay, 17 to 4. And what is the displacement of X then? After point C, displacement of X. Displacement of X will be how much? Half into base into height, and that is just 40 meters, just a mere 40 meters. It's just 40 meters. Good, that's it, finished. So difference between distances, so difference between displacements, you just have to subtract 280 minus 40, final answer 240 meters. In my opinion, this is the easiest approach, less messy. But if you feel this is bit, it's difficult to grasp this, the other option you have is now until 20 seconds, you have to find out the displacements of each train and subtract that. But I don't think that's a very good, method. I don't really recommend that. Better to go with this method, people. Better to go with this method. Okay, right.